Okay, we are on page 14. We're going to do this section for 2 days. We're very close to the end of the chapter, finally. Each chapter takes so long now compared to last year. All right. Okay, so these properties you already know because you had to use them to do the worksheet last week. So we are just going to kind of review the properties. All right, so let's take a look. So basically, if you have an exponential equation, and if the bases are the same, then you have to make the exponent the same. So we did that a lot last week, right, to solve the equations. Right, so basically, we've covered log and exponential and logistic functions, all that stuff, and then we analyzed them and all that good stuff. Now we're at the point where we're actually going to spend a lot more time solving these equations. Okay, same thing here. If you have two logs that has the same base, then the inside has to be the same. Okay, easy stuff. Okay, now let's take a look at this question. What should I do to solve this? Looks really crazy, but you can do this. Divide by 20 to both sides. Of course, you can solve this any way you want, but let's use the rule that I just showed you. Yeah, so if you change them so that they have the same base, then you can make the exponents equal and solve. So that's kind of the trick if you can't do it. If you cannot do it, then you got to do something else. Okay, so this is x equals 6. So pretty easy if they have the same base. Let's have you practice this one here. Let me know when you have the answer. The answer is x equals minus 4. Good? Does anyone need me to solve this one, or you guys are good? Okay, I take it from no nod or no expression, as in like I got this and I'm very tired. All right. Let's look at the domain. So we have these 3 graphs that represent these equations above. I want you to write down what you think the domain is. So write down what you think the domain is here. So I want you to talk to your partner and check your answers to see if you guys have the same domain. You can check with Seal. Both of you have no partners today. All right, let's see. Raymond, Y, and Andy. What is this first domain? This one on the left. Good. Okay, let's see. Shauna and Sunny.
It's bigger than 0.
Bigger than 0. And then Jingy and Wimble. That's the last one. This really strange one. Yeah, x is not equal to 0. Okay, obviously we've been practicing these graphs for a very long time, and we all know the domain. However, you need to keep that in mind when we're solving equations because it's not going to come intuitive. Okay. This first question. So we are going to solve this. Let's try by graphing. To graph, remember you gotta make it equal to 0 unless you want to look at 2 lines. It's much easier if you look at 1 line. So make it equal to 0, and you need to graph that. Please make sure you put a lot of parentheses on this so you're graphing the right thing. And you're looking at what is the value that's crossing the x-axis. Okay, were you guys able to find an x? What's the x value? 2.312. Okay, so that is graphically, you should be able to find the roots now, right, with your calculator. Make sure you keep that skill until next year when we do calculus. We're going to have to graph that kind of thing as well. Okay, method 2, algebraically. E to the x minus e to the minus x over 2 equals 5. Oh, yeah. All right, what should we do first? Multiply by 2. E to the x minus e to the minus x equals 10. No, we can't distribute natural log, so we can't solve this. So now is a tricky thing. Last year, someone told me a very fast way to solve this, but I forgot. Sorry, it was Ben. So if you see Ben, you can ask him how he solved it, and he showed me. I was like, oh, good idea. Now I forgot. Ben Yu. He's in calculus now. So a lot of them know him. So you guys can ask him and let me know, okay? Okay. Okay, can you show me later? We're moving on. Okay, so we are going to do it this way. So basically, we are going to multiply everything by e to the x. The reason being, we are going to get one of the e to the negative x into a 0. Okay, so this is going to be e to the 2x minus e to the x minus x. X minus x is, remember, if you have the same base, you add the exponents together. And then 10 e to the x. And then e to the 2x minus 1 is equal to 10 e to the x. Oh, okay. Now what? Now we have to get everything on one side. E to the 2x minus 10 e to the x minus 1 equals 0. Thank you. All right, now if you look at this, this is basically a question of e to the x squared, e to the x and something. So recall algebra 2, e to the x is 8. So we have a a squared minus 10a minus 1 equals 0. Yeah, so just basically it's a quadratic equation. How do I solve that? Huh? Quadratic formula, because I cannot factor this. So we have to use the quadratic formula. All right. Negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, that is 10 plus or minus square root of 100 plus 4 over 2. Okay, 10 plus or minus square root of 104 over 2, and then we got to use our calculator to solve this. So go ahead and get two numbers from here. What are the two numbers you got? 10.099 and negative 0.099. How come my answer is not the same as the graph?
Because it's
imaginary.
No. Yes, because what are we solving for? We were solving for e to the x, right? Our quadratic formula was for e to the x. So we have to substitute back. E to the x is equal to 10.099, or e to the x is equal to negative 0.099. All right, we got to solve for x. How do we solve for x? Okay, natural log both sides. All right, so first x is equal to natural log 10.099. What'd you guys get for the answer? 2.312. Okay, that is exactly the same as our answer. Then what about the second one? Natural log negative 0.099. Nothing, because you cannot take a log of a negative number. Remember, in our log, there's no number less than 0. That means you cannot put a negative number inside logs. Okay, so this doesn't work. Okay, so it's good. Our algebraic method and our graphic method is saying the same thing. All right, let us practice. Okay, so we are going to do this algebraically, and we can also check it graphically, but let's just do it algebraically. Okay, so again, use quadratic formula and, or not quadratic formula, but at least use substitution. If you can factor, factor. If you cannot factor, then use quadratic formula. Okay, once you have x, please let me know. So again, we want to use substitution. So this is 2a squared plus 5a minus 3 equals 0 if you let a equal e to the x. Okay, this one is actually factorable. So this is 2a and a plus 3 minus 1. Okay, so that is a equals 1/2 and a equals minus 3. Okay, a is really e to the x, so this is e to the x equals 1/2. And then to find x, we take natural log of both sides, so x is equal to negative 0.693. When a is equal to negative 3, so that's e to the x equals negative 3, take natural log of both sides, you can see that it doesn't work. You cannot take natural log of negative numbers. Basically, if you get a substitution problem and you get an a that's negative, you know it doesn't work. Any questions? Okay, let's try one more. This one, so notice how it has a 2 to the x and then a 2 to the negative x. Whenever you see a negative x, that's when you know you had to multiply by 2 to the x. Because you're trying to get it into a quadratic format. Like something to the something squared and then something squared plus something. And we couldn't do that with that one before. So go ahead and solve this one. All right, so, okay. So thank you, Ben. This is what you do. Okay, so first you multiply 2 to both sides. So 2 to the x plus 2 to the negative x equals 6. And then he said, well, 2 to the negative x is really 1 over 2 to the x, right? Then to solve this, you multiply everything by 2 to the x. So it's easier to see why you are multiplying 2 to the x to everything. Yeah, so it's more intuitive because you already know that kind of step before, so it makes more sense. So now it's 2 to the 2x plus 1 equals 6 times 2 to the x. So instead of like, why am I multiplying 2 to the x to everything? It was very confusing. You just turn that negative exponent to a denominator and say, I gotta get rid of the denominator somehow. So do that. Okay, once you have the answer, please let me know. Okay, 2 to the 2x minus 6 times 2 to the x plus 1 equals 0. So remember that you cannot combine the a and the b together into a 12. Remember, the base itself, the parent function, is 2 to the x. You can't multiply that into a function. Okay, so this is a squared minus 6a plus 1 equals 0. And then, solve that by quadratic formula. And once you have the answer, natural log both sides, x is equal to 2.543 and negative 2.543.
How'd you get? Oh shoot. Okay.
Are you guys good? Do you need me to finish this problem for you, or you're okay? Yeah, okay. All right, so quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so that is 6 plus or minus square root of 36 minus 4 over 2. So 6 plus or minus square root of 32 over 2 and then just get a decimal answer from there. Oh, did I do something wrong? No, it's right. Okay, and then just get decimal answer. And then once you are there, make that equal, so this answer is 5.828 or 0.1716. And then remember that both of them has to equal 2 to the x. Okay, one more step. So I'm going to solve one of them for you. 5.828 equals 2 to the x. How do I solve for x? Log base 2, but most of your calculators have no log base 2. 2 log? You mean log base 2, I think. Okay, so yeah, it would be nice if we have a log base 2, that 2 will be gone. But most of the calculators have no log base 2, so what should we do?
1 over another. Get log 5.8.
Yeah, just any log, as long as you take log of both sides. Okay, so log 5.828 equals x log 2. You don't have to use log. You can still use natural log. It doesn't really matter, as long as both sides have the same log. Okay, now we just divide. Okay, so x is equal to log 5.828 divided by log 2. Okay, and that's the answer. Okay, we'll do practice. Let's do the last kind. Logs. Solve this problem. What should I do to solve for x?
Log base 10.
Okay, it is a log base 10, but I gotta get rid of this log.
That's what they're
Ten.
saying.
Not multiply by 10. I don't want to multiply.
Raise to 10.
Can we
Raise by 10.
Can we just square root it? Oh, it's the
Oh, no, because it's inside. Okay, x squared is equal to 10 squared. What's the answer? What do I do next?
Square root.
Square root, yeah. And then x is equal to
10.
plus minus 10. Okay, the log problems are a little bit tricky. You have to plug it back into double check or really just kind of ask yourself, what's the domain? What's the domain of log x squared?
0 to infinity.
Everything except
0.
0. Everything except 0. So negative is okay because you're going to square it anyways. All right, okay. All right, I will send you the notes on this last one.